In the last video, we came up with a 95% confidence interval for the mean weight loss between the low-fat group and the control group. In this video, I actually want to do a hypothesis test to see, really to test if this data makes us believe that the low-fat diet actually does anything at all. And to do that, let's set up our null and alternative hypotheses. So our null hypothesis should be that, hey, this low-fat diet does nothing. And if the low-fat diet does nothing, that means that the mean, the population mean on our low-fat diet minus the population mean on our control should be equal to 0. And this is a completely equivalent statement. This is a completely equivalent statement to saying that the mean of the sampling distribution of our low-fat diet minus the mean of the sampling distribution of our control should be equal to 0. And that's because we've seen this multiple times. The mean of your sampling distribution is going to be the same thing as your population mean. So this is the same thing as that. That is the same thing as that. Or another way of saying it is if we think about the distribution, if we think about the mean of the distribution of the difference of the sample means, and we focused on this in the last video, that should be equal to 0, because this thing right over here is the same thing as that right over there. So that is our null hypothesis. And our alternative hypothesis is just going to be, I'll write it over here. Our alternative hypothesis is just that it actually does do something. That our mean, and actually let's say that it actually has an improvement. So that would mean that we have more weight loss. So if we have the mean of group 1, the population mean of group 1 minus the population mean of group 2 should be greater than 0. So this is going to be a one-tailed distribution. Or another way we could view it is that the mean of the difference of the distributions, x1 minus x2, is going to be greater than 0. These are equivalent statements because we know that this is the same thing as this, which is the same thing as this, which is what I wrote right over here. Now, to do any type of hypothesis test, we have to decide on a level of significance. We have to say, what we're going to do is we're going to assume that our null hypothesis is correct. And then with that assumption that the null hypothesis is correct, we're going to see what is the probability of getting this sample data right over here. And if that probability is below some threshold, we will reject the null hypothesis in favor of the alternative hypothesis. Now that probability threshold, and we've seen this before, is called the significance level, sometimes called alpha. And here we're going to decide for a significance level of 95%. Or another way to think about it, we want there to be, assuming that the null hypothesis is correct, we want there to be no more than a 5% chance of getting this result here. Or no more than a 5% chance of incorrectly rejecting the null hypothesis when it is actually true, or that would be a type 1 error. So if there's less than a 5% probability of this happening, we're going to reject the null hypothesis and go less than a 5% probability, given the null hypothesis true, that we're going to reject the null hypothesis in favor of the alternative. So let's think about this. So we have the null hypothesis. Let me draw a distribution over here. The null hypothesis says that the mean of our differences, so the mean of the differences of the sampling distributions should be equal to 0. Now, in that situation, what is going to be our critical region here? Well, we need a result. So we need some critical z value here, some critical z score, or some critical, I should actually say some critical value here, because this isn't a normalized normal distribution. But so there's some critical value here. There's some critical value over here. The hardest thing in statistics is getting the wording right. There's some critical value here that the probability of getting a sample from this distribution above that value is only 5%. So we just need to figure out what this critical value is. And if our value is larger than that critical value, then we can reject the null hypothesis, because that means the probability of getting this is less than 5%. We could reject the null hypothesis and go with the alternative hypothesis. And to figure out that critical value, and remember, once again, we can use z-scores, and we can assume this is a normal distribution because our sample size is large. For either of those samples, we have a sample size of 100. And to figure that out, we just have to figure out, the first step is to say, well, what is if we just look at a normalized normal distribution, if you look at a normalized normal distribution like this, what is your critical z value? Critical z value. We're getting a result above that z value only has a 5% chance. And to do that, so this is actually cumulative, so this whole area right over here is going to be 95% chance. We can just look at the z table. We're going to look for 95%, because this is a one-tailed. We're looking at the one-tailed case. So let's look for 95%. This is the closest thing. We want to err on the side of being a little bit maybe to the right of this. So let's say 95.05 is pretty good. So that's 1.65. So this critical z value is equal to 1.65. Or another way to view it is, this distance right here is going to be 1.65 standard deviations. 1.65 standard deviations. I know my writing is really small. I'm just saying the standard deviation of that distribution. So what is the standard deviation of that distribution? We actually calculated it in the last video, and I'll recalculate it here. The standard deviation of our distribution of the difference of the mean, the distribution of the difference of the sample means, is going to be equal to the square root of the variance of our first population. Now, the variance of our first population, we don't know it, but we can estimate it with our sample standard deviation. If you take your sample standard deviation, 4.67, and you square it, you get your sample variance. So this is the variance. This is our best estimate. This is our best estimate of the variance of the population. And we want to divide that by the sample size. And then plus our best estimate of the variance of the population of group 2, which is 4.04 squared, the sample standard deviation of group 2 squared. That gives us variance divided by 100. And this gives us, I did it before in the last, maybe it's still sitting on my calculator. So, yep, it's still sitting on the calculator. It's this quantity right up here, 4.67 squared divided by 100 plus 4.04 squared divided by 100. So it's 0.617. So this right here is going to be, this right here is 0.617. So this distance right here, is going to be 1.65 times 0.617. So let's figure out what that is. So let's take 0.617, and we can even add, well, I'll just leave it there, times 1.65. So it's 1.02. I'll go with 1.02. This distance right here. This distance right here is 1.02. So what this tells us is that there is only a 5% chance that the difference, if we assume that the diet actually does nothing, there's only a 5% chance of having a difference between these two means, the means of these two samples, to have a difference of more than 1.02. There's only a 5% chance of that. Well, the mean that we actually got is 1.91. The mean that we actually got is 1.91. So that's sitting out here someplace. So it definitely falls in this critical region. The probability of getting this, assuming that the null hypothesis is correct, is less than 5%. So it's smaller probability than our significance level. Oh, actually, let me be very clear. The significance level, this alpha right here, the significance level, I don't want to give you the wrong, the significance level needs to be 5%, not the 95%. And I think I might have said it here, but I wrote down the wrong number there. I subtracted it from 1 by accident, probably in my head. But anyway, the significance level is 5%. The probability, given that the null hypothesis is true, the probability of getting the result that we got, of the probability of getting that difference, is less than our significance level. It is less than 5%. So based on the rules that we set out for ourselves of having a significance level of 5%, we will reject the null hypothesis in favor of the alternative, that the diet actually does make you lose more weight.